Welcome to this session on assessing risk, where we'll explore how businesses can model uncertainty and make informed decisions under risk. Let's get started. Risk is the possibility of an undesirable outcome occurring. Risk analysis, also known as scenario analysis, involves examining different scenarios to assess both intended and unintended outcomes. By using random variables to capture uncertainties, we can make better informed decisions. To effectively assess risk, it's essential to examine multiple scenarios. The most likely scenario is the typical or average outcome. A pessimistic case is a worst-case scenario that depicts the lowest potential performance. An optimistic scenario is the best case with the highest potential performance. Historical data can help estimate realistic, most likely, worst, and best case scenarios, providing a clearer picture of uncertainty in real-life processes. Consider a company that manufactures and sells handbags. Here are the variables. The variable cost per handbag is $40, but it can range from $35 to $46. Fixed costs of $43,000, but can range from $31,000 to $52,000. A retail price of $65 per handbag. Quarterly demand is typically 3,500 handbags, but it can range from 2,500 to 5,000. Using risk analysis, we can calculate quarterly profit. Profit equals the retail price minus the variable cost multiplied by demand minus the fixed cost. To analyze this scenario in Excel, open the handbag worksheet in the resources section of this module. Then apply the profit formula across different scenarios. Use historical data to define the best, worst, and most likely cases. Then calculate profits for these scenarios to assess variability in outcomes. This allows the company to evaluate potential risks and plan accordingly. The steps depicted on the slide are also in the textbook. Follow the steps as instructed to determine a best, worst, and most likely scenario for profit. The triangular distribution can represent the worst, best, and most likely scenarios. This distribution will display the highest point at the center of the distribution and is most often representative of the mode or average. Random variables are numerical values assigned to the outcomes of an experiment, helping model uncertainty. Discrete random variables can be uniform, binomial, or Poisson. Continuous random variables can be uniform, normal, exponential, or triangular. Understanding the shapes of these distributions helps businesses choose appropriate models for their data. The shapes of some but not all of the different distribution types are presented here. Sometimes generating a histogram to view the shape of the data can drive the choices you make in random number generation for risk modeling. To use the random number generator, we will need to use the data analysis add-in for Excel. Follow the steps presented on this slide to apply the tool pack to your data ribbon. Let's practice using the random number generator. Select the Data tab, then the Tool pack, then Random Number Generator. Enter the inputs as displayed on this slide. Your results will look similar to what is displayed on the slide, but they will not be exactly the same because it is a random generation. This concludes the lecture on assessing risk. Thank you for your attention.